Greetings and salutations. This is the 2020 annual meeting for the Coalition for Excellence in Science and Math Education, and my name is Jesse Johnson. As you can tell, we are an organization that cares about improving math and science education, not only in our home state of New Mexico, but across the entire United States as well. And we believe in making data-based decisions to bring about that improvement. Before I get started and introduce the speaker, I have a couple orders of business. If this is your first time on a live stream on YouTube, and some of you that may be true, if you have a YouTube account or a Google account, on the right is a chat that you can enter chats into. You can interact with your fellow watchers and you can ask questions, and I might pick a couple of questions from the live chat. Also, if you like the idea of me contacting other scientists to talk about their work and other issues regarding science, you can go ahead and look down below. There is a subscribe button. If you click on that, a bell will appear. If you click on the bell, it will give you the option to receive all notifications. If you do that and enough people subscribe, I will seek out other scientists to talk about their work for your entertainment and education. The final order of business before I get to introducing our speaker: what is science? Well, science is a methodology. It is a methodology to derive natural explanations for natural phenomena. It requires empirical observation, but it also requires something else that is very important, and that is mainstream peer review. You have to put your research out there so that experts in the field can throw rocks at it. And if your work does not stand up, it is not science, and either you alter your conclusions or you come up with new ones. And also, one other thing with science is it has an underlying assumption, and that is that there is an objective reality. That is to say, I can set up a physics experiment here in New Mexico, and somebody on the other side of the planet in India with a very different culture can do the exact same experiment, and they will get the same results. With that being said, our speaker is Mark Boslough, a world-renowned physicist and one of the global experts on interplanetary impacts. I would say you can throw rocks at Mark in peer review, but he deals in big rocks, meteors, and comets. With that being said, Mark, go ahead and take it away.
Well, thank you so much for the introduction, Jesse, and I really appreciate CESE and everything you do. I was actually on the board. I think it was the very first board when Marshall was president, way back in the late 90s. And it was and I haven't done it since, but I really appreciate those of you who do. So I'm going to give a really kind of three stories here, and they all kind of center around the same theme, and that's the importance of astronomical drama and the importance of astronomical drama to humans. The first story involves me personally, and how the trajectory of a small asteroid affected my trajectory and my personal understanding of what Jesse just articulated about what science is: natural explanations for natural phenomena. And it goes back to when I was a teenager. In the summer of 1972, it was just before I was to start my senior year in high school. And my family went on a vacation to Grand Teton National Park, and I'll go into that story. But first, I just want to list the three stories I'm going to tell. And if you look at these titles, I didn't realize it when I wrote them. It looks like a list of headlines that you might see in the National Enquirer. But in a way, I think subconsciously, I was really thinking about the difference between science and pseudoscience or the paranormal. And people are very attracted to pseudoscientific or paranormal explanations for things. They get a lot of clickbait, but all of these have natural explanations. So I'm going to start off with this UFO over the Tetons. And if you look carefully, you might not have seen it in my introductory slide. Oh, and I'm forgetting to tell Jesse to forward. So can you forward the next couple? I'm pushing my own button and seeing my own display. So yeah, go forward. I'm sorry, back one. There we go. Okay, we're synchronized now. So this was 48 years ago, August 10th, 1972. And if you look carefully, directly above the large peak on the right, you'll see something streaking through the sky. And I, even though it affected me, I didn't actually see it, and nobody in my family saw it. We arrived at that spot literally minutes after it happened. And I wrote a story that was a blog that was published in the Huffington Post on the 40th anniversary of that. And I just want to bring it up in the next slide and read through it, because this actually got it a little bit of attention, and I learned more because of the feedback I got from writing this. It was one of those picture perfect late summer afternoons in the Rockies. 40 years ago, on August 10th, 1972, I was a teenager on my last real family vacation before starting my senior year in high school. We were camping in Grand Teton National Park. The sun was high and a dark blue sky was blotchy with white clouds. My sister and I had been swimming in a surprisingly warm Jackson Lake, getting sunburned and lazing around our family's campsite. After lunch, we all decided to pile into the car and drive through the pines to the Indian Arts Museum at Coulter Bay. Next slide, please. When we arrived, we noticed that something out of the ordinary was going on. Groups of people on the lakeshore were engaged in animated conversation, looking at the sky and gesticulating. People were really excited. There was some kind of electricity in the air, and their excitement was contagious. I asked a man what was going on, and became perhaps the first of perhaps hundreds of people to listen to the story of what he had just seen. A UFO, he said, had just streaked across the sky from south to north. I remember his words and the exhilaration in his voice as he described it. It was a ball of flame, almost too bright to look at, maybe as big as the moon, shedding sparks. It left a trail, and it was moving so fast. Others chimed in with their own descriptions. No way was it an airplane, they said. It was a UFO. People lingered, wanting to talk about it. I felt left out because I had been in the car and I'd missed it. My whole family had missed it. Next, please. So when I was a kid, I loved to read about UFOs, and I always wanted to see one. I read popular accounts and watched TV shows about them. Once I found a book at our local library called UFOs Identified. The author was Philip Klass, a skeptic who investigated UFO reports and explained them in terms of natural or man-made causes. Klass's book changed how I thought about unusual phenomena. And it turns out that Philip Klass was a fellow of what was then called CSICOP, is now called CSI, Committee for Skeptical Inquiry, which our sister organization, New Mexicans for Science and Reason, is affiliated with. It was so much more fun and challenging and honest to try to explain such things with science and the laws of physics. To attribute them to some mysterious or supernatural unknown is intellectually lazy. It is a shrug at the glory of nature. Paranormal explanations are an uninteresting cop-out. Klass put me on the path to science and skepticism. That afternoon at the Tetons, I remembered one of those case studies in which he had meticulously plotted out sight lines and calculated the timeline of one famous historical UFO observation. He showed that it was almost certainly a meteor that had been seen by others, but that the angle of the observation from directly downrange made it appear to hang in the sky and move in an unnatural way. I wondered if somebody couldn't do something like that for this Teton event and figure out exactly what it was. So I was already, even though everybody that I spoke to interpreted it as a UFO, an alien visitor, or something paranormal or unexplainable, I thought I'd read Klass and I was immediately skeptical, and I thought this should be something that could be figured out with science. But that was 1972. There was no internet. There was no easy way to find out what really happened. We were camping. I didn't have a newspaper, and by the time we got home, if it had been in the news, it was out of the news. But fast forward, one more slide, please. So in 2 years later, I was entering my sophomore year at CSU. And people who are my age, plus or minus about 10 years, probably remember this guy, Tom Snyder. He had a show called The Tomorrow Show. And if you don't remember him, you probably remember Dan Aykroyd's impersonation of him on Saturday Night Live. So he had a show, and we used to watch it in the dorm room. It came on late. It came out on after Johnny Carson. And he would interview people who had paranormal experiences. I mean, he interviewed rock stars like John Lennon and David Crosby. He interviewed politicians like Ronald Reagan and George McGovern. But he also would have, ESP people on, and UFO people, and astrologers and whatnot. And I remember watching the show, and there was a teaser, and it showed a clip of a video that I had never seen before. It was a video of that 1972 event. And he had a guest on who described it, and indeed, it was a natural event. It was an asteroid streaking through the atmosphere. It was coming in at a grazing angle, and they described it as skipping out of the atmosphere. So it came in, it went back out, and I one of the things that really struck me was the guy he was interviewing said if it had come in at a steeper angle, it would have exploded with the explosive power of a nuclear explosion like Hiroshima. And I was thinking, geez, I didn't know we came so close to having a catastrophe. And I thought about it for years after that. And it was one of the things that so much attracted me to the study of asteroids, and also to skepticism. Next slide, please. So if you go to the next one, it'll actually show that video. And then let's see the next one, Jesse. Oh, I'm sorry. I think I had it. Okay, if you go back, there's a video. I'm not seeing it on the display, but maybe you're seeing it. I don't know if you're seeing the video of the asteroid streaking through the sky. It's okay. You might have to click on the little box. I had it set up on my version. It automatically plays, but I apologize that you don't get to see it.
Yeah, no, it's.
We'll have to arrange to put that up later.
Yeah, I can upload it as a video.
Okay, yeah. So let's go to the next one, and I'll finish out my story. So as it turns out, somebody actually did that. Somebody did what Philip Klass did. The object was seen by hundreds of people across several states in Canada. Its path could be worked out, demonstrating that it was a large meteor on a grazing trajectory. It also became the very first meteor fireball ever recorded by an infrared sensor on a U.S. Department of Defense satellite. Actually, that's not strictly accurate. It wasn't the first to be recorded. It was the first one to be recognized as useful information and archived. It entered over the atmosphere over Utah and descended to about 53 kilometers above Montana before its momentum carried it back up to its escape over Alberta. It was probably about 3 meters in diameter when it entered, but much of it was melted and vaporized. There's actually a huge uncertainty. It could be have been as big as 10 meters. Because of this careful science, we now know that somewhere out in space, there is a tiny asteroid with a thin, glassy crust, a fusion crust. It got from the minute it spent rocketing through the Earth's atmosphere as the great daylight fireball of 1972. Such is the glory of nature. So my lesson is natural explanations for natural phenomena are much more fantastic and really are one of the reasons they're so much more interesting is because if it was still a mysterious UFO and people were speculating, well, maybe it was a little green man, maybe it was this, maybe it was that, we don't have to speculate. We know what it was. We know when something goes through the atmosphere, the heat causes the surface to melt, and then it refreezes and creates a fusion crust. So we know there's a small asteroid out there somewhere with a fusion crust from passing through the Earth's atmosphere. And if there was one that was recently enough to have observed, it's probably happened many, many times throughout history and prehistory, which means there are a lot of them out there like that. To me, that's the glory of nature. using science to figure stuff like that out, to me, is just inspiring and amazing. So little did I know, next slide, please. Little did I know at that time that those satellites had been developed during my childhood. This is the first one at Sandia Labs. The bang meter, the actual sensor on this satellite, was designed by a young engineer named Dick Spalding. A lot of you probably remember Dick Spalding. He has come to give presentations at our NMSR meetings. He passed away 3 years ago, just before I retired. We worked together. We published a paper that came out about 1 month after he died in 2017. But Kennedy, when he came to Sandia in 1962, there's a famous photograph of him with that Vela satellite. There were other satellites. Next slide, please. Other satellites that, thanks to Dick, in large part Dick Spalding's efforts, who recognized the scientific importance of seeing these bright lights, these flashes that weren't nuclear explosions. These satellites are there to determine whether or not there are clandestine nuclear explosions, but most of the explosions in the sky are not nuclear explosions. They're asteroids. And Dick recognized the importance of preserving that data and using it to characterize and quantify and understand the process of asteroids colliding with the Earth and exploding in the atmosphere. And only a few years ago did this start getting released, declassified and released to the public, and is now posted on the Jet Propulsion Laboratory's website. And I just downloaded this one yesterday. This is the latest map of the last several decades of worth of explosions. Now, the early, 1988 through the mid 90s or so, a lot of them were thrown away. So they're not statistically accurate, but the more recent ones, they release almost everything above a certain threshold size. You can see the big red one in Russia. That's the Chelyabinsk event that happened on Valentine's Day in 2013. It was a half a megaton. Next slide, please. So Ed Taliaferri, I got to know him in the 90s. He was a colleague of Dick Spalding's, and he was responsible for the infrared measurements. So there are visible measurements that were done by satellites like Vela with the bang meters, and there's also infrared. And it was an infrared satellite that observed this 1972 event. And so the object is still on an Earth-crossing orbit. So there was another colleague, a Czech scientist by the name of Zdeněk Seplika, who did some very careful analysis of the satellite data, as well as the ground-based observations. And he was able to estimate the trajectory and calculated an orbit and determined that it would come back close to the Earth in 1997. And of course, it was very tiny and the uncertainties were large, so it wasn't observed. Next slide, please. Well, so after I published this Huffington Post blog that I read to you, Don Davis, who's a well-known space artist, said, hey, there's another picture of that. I used to work for an observatory in Salt Lake City, and somebody sent us a slide that they took for somewhere in Utah, I don't know where, he said, and it shows the same thing. And so he sent it to me, and he said, well, he didn't remember who took it or where it was taken from. He just remembered it was taken from Utah. So a couple of years after that, so the 40th anniversary was 2012. A couple of years later, I gave a presentation at the IEEE Aerospace Conference in Big Sky, Montana, and I showed this slide, and several people in the audience said, hey, I know where that is, except they didn't all agree on where it was. Some of them said, oh, it's the top of the tram at Big Sky, and somebody else said, oh, it's the top of the tram at Jackson Hole, and somebody else said, no, I think it's in Utah. And we ended up adjourning to the bar and going on Google and Googling ski area trams, and we ended up finding it, and it turns out it's Snowbird, Utah. And the next slide, if you look at this one carefully, go back one, please, Jesse. I forgot to say. So if you look at the skyline and you look at if you look at the top of the tram tower, there's kind of a W shape there, and there's a ridge that goes up to the left of that, and then you can see the skyline. Now, if we go to the next one, you can see that exact same pattern. So clearly, it's obviously Snowbird. So why is this useful? What this means is that you could go to Snowbird and you could take a photograph at night at a particular instant in time where you know your coordinates and you know the precise declinations and or azimuths and elevation angles of a star at that instant. You can identify the star, and you can actually put like a 2D ruler across the sky, and you can determine exactly what that trajectory of that object is from a very different vantage point. So I think what we could do is go there, and I haven't done it, and it's been 6 years now. I've always wanted to go to Snowbird and get permission to go there at night and take these photographs and recalculate what Seplica did, and see if I can get a better trajectory on this object, and maybe publish a paper with better orbital elements for the outbound asteroid. Next slide, please. So here's what here's Seplica's orbital elements, and the really important one is the semi-major axis, because that determines the orbital period. There's eccentricity, that's the shape. There's inclination, that's how much the orbit tilts relative to Earth's orbit. But you can see it's the more elliptical one that's got the label on it, and Earth is the second full circle that you see, and then you see where the intersection point is. And you can see there's uncertainties on everything. The one with the least uncertainty is the longitude of the ascending node. That's known exactly, because we knew the ascending node is right where it passed the Earth. So we knew the instant in time and exactly where. So there's no uncertainty on that. But there is uncertainty on the other values. Let's see, next slide, please. Yeah. So I mentioned from the semi-major axis, the size of the orbit, you can get the orbital period. That comes straight from Kepler's third law. And so if you apply Kepler's third law, you can determine the number of years it takes to go around once. And if you do that, basically you multiply the semi-major axis, or you take it to the 3/2 power, and there's some uncertainty on that. And then if you multiply that by 14, you can estimate how many years it takes for 14 orbits of the asteroid, and it's exactly 25 years within a few days uncertainty. And that's why Seplica said it would return in 1997. Well, okay, now another 25 years has almost gone by. 24 orbits is 50 years. Well, that happens in 2022. So this thing's going to come back past in 2022. I don't for a minute think that it's going to be observed, but it's cool to think about. And I would love to go back and do those measurements at Snowbird and do a better calculation before it comes back. And if by some miracle it actually comes close enough to see, remember this thing is tiny, 3 to 10 meters, probably not going to be seen. But you never know. If it's seen, it could be matched, and it would be that object that would have a fusion crest. Next slide, please. Let's see. Yeah, there we go. Okay, so part 2, King Tut's cosmic bug. And some of you have probably seen me talk about this. I gave a talk about it at NMSR. And I'm going to kind of give an abbreviated version of that talk. Next slide shows what the cosmic bug is. I don't think the ancient Egyptians knew that it was cosmic. But if you look at this, this is a breastplate or a pectoral, an adornment that was found in King Tut's tomb. And the little scarab, the dung beetle that's in the middle of it, is a kind of a cloudy piece of this yellow, mysterious yellow-green glass that's found in the western desert of Egypt. I got to go there in 2006, 14 years ago. And I was able to find and pick up some pieces. And let me show you one. I think you don't see me full scale in what you're looking at, but this is what it looks like. The clear pieces are just gorgeous. But it's nowhere near the Nile Valley. If you pick up a piece, they're of all sizes, and some of them have darker material in them. And it turns out that that darker material has been analyzed, and it's enriched in platinum group elements, in particular osmium. That suggests that it's extraterrestrial, that it has some extraterrestrial source, like an impact. And impacts do produce glass. Next slide, please. Impacts do produce glass. It was almost or about 60 years ago that Meteor Crater, Arizona was determined to be an impact crater. For a long time, scientists had speculated it was an impact crater, but there was a lot of resistance. And because science is so conservative, you really have to, as Jesse said, get everything through peer review. And the burden of proof is really on the extraordinary claim. And it was an extraordinary claim at that time to say that this was an impact crater. And part of the reason, part of the reason that there was resistance was because there are other things that make craters. There are volcanic explosions and other things. But Gene Shoemaker, who was doing research on this, figured out that if he could show that there were high pressure phases of the target rock, if target rock, you all know that if you squeeze carbon or graphite enough, it forms diamond. It changes phases and forms diamond. Well, the same thing is true with quartz. Quartz is a mineral that is in the sandstone that is the target at Meteor Crater. If you squeeze it hard enough, you can make high pressure phases called coesite and stishovite. And Shoemaker showed that this existed in the rocks at Meteor Crater, and therefore Meteor Crater is an impact because you can't get pressures like that on Earth any other way. So science is very conservative. Now there's also glass there, but the glass looks nothing like Lydian desert glass. Next slide, please. So in a solid impact, and we always thought of impacts on Earth as solid impacts, just like on the moon. Forget about the atmosphere. The atmosphere is too thin to affect anything. And this is the process. This is Gene Shoemaker's kind of cartoonish sequence of how you form an impact, a very high pressure process, high temperature, but also high pressure. Next slide, please. Well, in 1994, this comet, it was actually discovered in 93. It was determined to be on a collision course. It was discovered by Gene Shoemaker and his wife, Carolyn, and David Levy, their partner, an amateur astronomer. And it had broken and pieces were falling into Jupiter one at a time. Well, Jupiter has no solid surface. So the question is, what happens when there's an impact into an atmosphere with no solid surface? Well, I and my partner, Dave Crawford at Sandia at the time, and the next slide shows a cross-section of our simulation that shows what happens. You get a big, enormous explosion and very, very high temperatures and a shock wave. So that turned out to be visible from Earth. Now, we made this prediction before the impact, and this is another one of those extraordinary claims. When we ran the simulations, people were very reluctant to believe us that this was real, but the extraordinary evidence is on the right-hand side of the next slide. The Hubble Space Telescope images of this plume rising over the horizon of Jupiter as seen from the Earth. It's rising over the limb. That gave our airburst simulations a lot of credibility. So the next slide just shows a very, very bright infrared radiation observed from the Earth. by observatories on the Earth. So very, very large energy, a lot of heat coming out of this thing. The next slide just kind of shows a cartoon of us watching what was happening on Jupiter, but not paying attention. This era of the mid 90s was about the time we really started thinking in terms of planetary defense. If these things are headed towards Jupiter, they're also headed towards the Earth. And the next slide shows the effects of an explosion in the atmosphere. This is Tunguska, June 30th, 1908. This is the aftermath. These photographs actually weren't taken until something like 20 years after the event. But there was an enormous blast wave, no crater at all, just a lot of damage to the forest. So clearly something exploded in the atmosphere. Now Tunguska is another example of imaginations gone crazy. And there's lots of paranormal explanations for that, or sort of pseudoscientific, semi-scientific. A black hole exploded, antimatter exploded, a UFO exploded. The Russians love the UFO story. But it's perfectly explainable in terms of an asteroid explosion. And the next slide shows the ground maps that Dave Crawford and I created by doing simulations, very much the same, I mean, almost identical to the types of simulations that we did for the explosion of Shoemaker-Levy 9 in Jupiter. And because our predictions matched the observations, people were much more likely to believe us on this one. And our map is on the bottom right. That was the map we created for the pattern of tree fall, and the map above it is the actual map based on field data, field explorations of the Tunguska site. Next slide, please. So this scarab got a lot of interest in the late 90s because Vincenzo De Michele, a mineralogist, Italian, he identified it. So this scarab had this breastplate had been known about for years. Nobody knew what mineral the scarab was made out of. De Michele was familiar with the Libyan desert glass. He recognized it, and he confirmed it in 1998. And it got a lot of press. And ultimately, there was an expedition to Egypt for a documentary production, and I was invited along because I had done these Tunguska simulations, and I had speculated about the cause of the Libyan desert glass. It was an impact glass, but it wasn't from the shock wave, it was from the heat. Remember that picture, Earth-based picture of the bright in flash, that's basically heat radiation coming from Jupiter. Well, if that happened on Earth, that infrared heat radiation is not just going out to space, it's also coming down to the surface, and that was my idea. The next slide shows an article that inspired the documentary that didn't get produced until 2006, it took him 7 years. But this was an article based on an abstract that I presented. My little part was based on an abstract that I presented at a meeting in Bologna. It was a Tunguska, a combined meeting between people who were interested in Tunguska and people who are interested in the Libyan desert glass. And it showed up in New Scientist. And then it became the weird story of the day. The next slide shows the Discover magazine, the Weird Year in Science, took this and said, well, this is a crazy idea. And it was kind of a little bit dismissive. But I really, it was another extraordinary claim. Let's put it that way. Next slide. So documentaries, some documentaries are filmed with kind of a reality show element. This is only the second documentary I'd ever been in. And they took 3 of us out to the desert, the western desert of Egypt. And the 3 of us all had different ideas. And I was the promoter of the airburst idea. Next slide, please. So here's where one of our campsites between the dunes, and there was Libyan desert glass scattered all over this area. And here's a piece. The next slide shows a piece, and I think that is actually the piece that I held up. So there it is. Let's see. Let me line up here. So that's the piece. There were a lot of pieces. And this stuff has been determined to be over 29 million years old. Silica glass is super stable. And so even though there's been many climate changes, there were probably rivers flowing through this area and it was lush and green at one time. Now it's desert. This stuff has survived. You can see that it's most of the weathering is mechanical from windblown sand. Next slide, please. And I hope this one plays. You might have to click on it, Jesse. I had it set up to, oh, they're not playing. Okay, well, this, if you could see it, and I can see it on my monitor, we'll put these up. This shows my simulation of an asteroid coming in and creating an enormous fireball and cascading downward and forming a crater, but most of the energy goes into the atmosphere. And fortunately, we did test the animation, the CGI version of this, which is actually much better. So if you go 2 slides ahead, you will see the National Geographic documentary.
30 million years ago,
and also
an asteroid was on a collision course with Earth, heading for Egypt.
There is narration. I can't hear it, but I hope.
As it began to burn up, it created a hot plume in its wake. Before reaching the ground, it exploded into a blistering fireball. Surface temperatures immediately reached 1,800 degrees Celsius. The ground, which was mostly sandstone, melted and was transformed into yellow-green glass. Above the surface, a column of superheated gas propelled itself into space. The total effect was far more devastating than if it had simply hit the ground.
Okay, so one of the interesting things about that simulation is it shows very, very high speed wind and very, very hot, nearly as hot as the surface of the sun, blowing across the surface at supersonic velocities, frothing everything up, melting everything like a blowtorch on wax. It's like almost like the way creme brulee is made, the crust on creme brulee. And then because when something cools very fast, it does not have time to crystallize. It forms glass. And all the pieces you see in gem and mineral shows and for sale on eBay, pretty much everything is the really pretty stuff I've been showing you. But if you go out to the Western desert, you find stuff that looks like this. It looks like shaving cream. It looks like frozen shaving cream. And I think that's the froth on top. So this is still unproven. Not everybody believes it. We're looking for more arguments, but it's, in my opinion, an extraordinary claim. We know what the flux of asteroids hitting the Earth's atmosphere are. We know there's a power law distribution, more small ones than there are big ones. That map I showed you of the U.S. sensor data that looks like the Earth has measles. There were a lot more small ones. There was only one big red one. That was Chelyabinsk. And as you go to bigger and bigger, they're rarer and rarer. But the bigger ones have this flamethrower effect where they come down to the surface and they incinerate or melt the entire surface. So my last bit is going to be on American Stonehenge. That sounds a little paranormal-ish too. It is more speculative than the other ones, but it's fun to think about, and it's about something we know actually happened. So let's go to that one next. So next slide, please. So I went to there's something called the Pecos Conference, named after Pecos, New Mexico, and it's a conference of amateur archaeologists that get together with professional archaeologists. And my mom has been a real fan of this. She used to come every year. It's not always in Pecos. The first one was in Pecos, but it moves around mostly in the Southwest. It's actually been across the border in Chihuahua, Mexico, usually in one of the Four Corners states. The first one I went to was in Pecos. And I hadn't been to one for years. But in 2015, my mom, who used to go with friends, her friends took her to one that was in Mancos, Colorado, which is kind of between Durango and Cortez in the southwestern part of the state. And, you know, I was mostly there just to visit with my mom and hang out. Everybody camps and they set up a tent and speakers give presentations in the tent. And there's a lot of beer. It's really fun. So I went to a talk. I saw something about eclipses and I thought, oh, that sounds interesting. And there was a guy named Don Simonis, an archaeologist, who gave a talk and described the fact that during the peak of the ancestral Pueblo people, sometimes called Anasazi, there were 2 total eclipses of the sun in that Four Corners area within 28 months of one another, just over 2 years of one another, which is just remarkable. I mean, it's got to happen, but it happened there and it happened at that time. And there were people living there and it was observed. And then he said, well, there's a place in southeastern Utah in Cedar Mesa, Bears Ear, what is now Bears Ears National Monument. And it was within that area, he said, and interestingly, he said, they've done dendrochronology on the vigas, the timbers that were used to construct this place, and they date from exactly that time. So, and it also has some interesting art that looks like it might depict eclipses. So I went home right after that conference in August of 2015, and I went directly to the NASA website that shows all the historic and prehistoric eclipses, because the solar system runs like a clock. Things are predictable pretty far into the past because the uncertainties are so low that you can extrapolate and you can know exactly when things happen and where. And that's certainly true with eclipses. So one of the eclipses, the anniversary of the second eclipse, converting from the Julian calendar to the Gregorian calendar, is on October 22nd. So I organized a group. We went up there to visit on the anniversary of that eclipse, because I kind of wanted to see if any evidence, if anything would display. So astroarchaeologists use the term to display to describe when there are certain alignments that look like they aren't by accident. And I wanted to see if there was something that they had set up to record this event. And so these are my field trip notes. So if we go to the next one, let's see. Okay, here we are. Yeah, that is from the NASA website. So you can see the states there. The center line is, I think, GE stands for greatest extent, the little green bubble, the kind of reddish line in the middle, and then there's 2 tracks, parallel tracks curved. That's the edge of the extent of totality. And the moon house on Cedar Mesa is just, well, there's like a little bubble pointed to it with various data showing exactly the date and time that it started. Now this is the first eclipse. So this is the one in 1257 that happened. It shows on 1213. I'm sorry, on June 13th. That is the Julian calendar. When you convert it to Gregorian, it turns out to be right on the summer solstice. And what is remarkable with this, and I'll blow it up in the next slide, it's zoomed in a little bit. Totality starts, I think this is a mistake. I think it's actually after local noon. So So noon, astronomical noon, isn't when the clock says 12 o'clock or 1 o'clock on daylight savings time. It is when the sun crosses the meridian. And you can look that up as well. And so these times are incredibly close to noon on the astronomical noon, which is the only thing people before they had clocks cared about, because the sun was the clock. This happened within 10 minutes of local noon on the summer solstice, which was a very important day to these people, which to me is just remarkable. And it was a very long eclipse. It was 2.5 minutes long, which is that's a long duration of totality. It must have been terrifying, and it clearly affected these people. And the date of when those pieces of wood were harvested indicates that it was built probably immediately after that place. The next slide shows one of the decorations on the on the east wall, which kind of looks like a total solar eclipse, although you can interpret things many different ways. Does it depict the eclipse at zenith at 12:57? Looks like it could. But here's the interesting thing. The second eclipse, if you go to the next slide, it was a total eclipse. You can see that it crosses the same part of Colorado, the Four Corners area. Let's go to the next one to zoom in. So you saw the other one crossed Cortez, Mancos, Colorado, Durango. Anybody in those areas would have seen two long duration total eclipses. But when I went to the NASA site and put in the actual coordinates of the moon house, it's just barely outside totality, which means it was never a total eclipse. The second one was not a total eclipse. But the people who lived there clearly were tuned to eclipses and noticed that the sun got dark and paid attention. Next slide, please. So what they saw was probably something that looked like this. Diamond ring eclipse, almost, but not quite total. If you looked at the previous slide, I forgot to point it out, but it was 99.99% total. So 0.001% of the sun was exposed. That's still a lot of photons, but it's going to look something like this. Next slide, please. Well, one thing about crescent moons at this latitude, at mid-latitudes, is when you see a crescent moon in the night sky, it reclines. And that just has to do with the geometry of the solar system and the way the Earth orbits the sun and the way the moon orbits the Earth. When you see a crescent moon in the evening, it reclines and it looks this way. If you see it in the morning, it reclines and looks the opposite way in the southern hemisphere. It's the other way around, and it's weird. And most of our art reflects that. Cartoons. Go to the next slide. You see these kinds of cartoons all the time. They always show crescents. Artists always show crescents reclining. I mean, think of the DreamWorks, the DreamWorks logo, the kid fishing. They're always sitting on the moon because it reclines. But a solar eclipse doesn't necessarily do that. Next slide. So crescent moon in the sky reclines, crescent moon in the crescent sun not so much. And as the moon crosses the sun, the crescent actually changes orientation very rapidly. You can watch that happen. Next slide. So if you look at the west wall, the south, I think it's the west wall, but I could be mistaken. I forget which way it's oriented. If you look at that, you see a crescent that is not inclined, and that is actually what they would have seen in the sky from that location. They wouldn't have seen a total eclipse. They would have seen a crescent at its maximum, or as it approached the diamond ring stage, and it would have looked like this with the horns pointed to the left. Next slide, please. So this is one of the locations. This is part of the moon house. There's this crack, and the crack runs north-south. And so slits and pinholes are great ways to track the path of the sun. And they actually have a structure there. The archaeologists say it was a granary, or it was used to store food or corn. But it sure looks to me like if you wanted to track when the sun passed the zenith, you'd find a crack like this and you'd set something up underneath, maybe stack rocks or whatever to mark times and passages. And so maybe this was a solar observatory. Now, again, this is speculative. And unlike the kind of physics and astronomy that we think of as science, archaeology is one of those historical sciences, and you can never know for sure. Maybe you can make predictions. Maybe there's something we could think of to confirm it, that at least they were doing things to try to track the sun. That's why I went there on the date of that October 1259 solar eclipse. I want to go there on the summer solstice. The reason, in fact, that we're having this meeting today instead of last weekend is because last weekend was the summer solstice and we planned to go. We ended up canceling at the last minute because a lot of our friends were canceling for various reasons, and we just decided now is not a good time to travel. So we want to try again. Next slide. So this was the end of my last slide. And remember, this was my field guide for my 2016 adventure. We had planned to go the following summer. We didn't. It turns out that Yvonne and I were on our honeymoon on that date in Norway. So it's a good thing that we didn't plan that. We did, next slide, we did actually make some plans on that date. I proposed to, who was then my girlfriend, my wife Yvonne, I proposed to her in the moon house at the time of the diamond ring, the anniversary of the time of the diamond ring phase of that historic, almost total solar eclipse. Next slide. And one of the things that I gave her was a meteorite from an airburst over Chelyabinsk. I went and collected meteorites in 2013, and we had our rings made out of that meteorite. So that is, we have our Chelyabinsk rings, and we got engaged on October 22nd, and we got married on April 22nd, Earth Day. Next slide. So I did write this up. It was published in Astronomy Magazine. I'm not going to read this one. The letters are too small to read, and it's a lot longer, but I do have it online. If you just Google my name and American Stonehenge, it'll turn up. Actually, what'll turn up first probably is a Huffington Post, but you can click on the PDF and it shows all the pictures. Next slide. And these are just pictures that I took, including some of the ones that I showed. Next, please. I was looking for sunbeams. I was looking for these kind of displays. You would expect to see, if they were really serious, you would expect to see something on the summer solstice, which is very much why I want to go. Next slide. So it turns out, I wasn't completely aware of this, but there was an almost total solar eclipse last weekend on the solstice, but it wasn't observable from this hemisphere. This is a photograph that was taken from Taiwan. And then my last slide, before I finish here. Now you saw my last slide of my field guide. It didn't work out, but I still want to do a field trip to Utah. I would like to do it next summer solstice. And I would also like to go to Snowbird and figure out how to get to the top of that tram and do the stellar calibration and recalculate the trajectory and the orbit of that 1972 Great Fireball, because it will probably return a year after that. So anyone who wants to join us for this expedition, you either know my email address, or you can find it online, or you can ask Jesse or one of us, and we'll be happy to provide it. So thank you for inviting me. I've never given a presentation like this. It's interesting to get no audience reaction, but you're welcome to ask me questions afterwards.
Okay, let me hop back in here. So we're going to go over, CESE does have a membership, and I'm sure some of them have questions. But before we do that, one person in the chat commented that the simulation reminded him of a nuclear blast. I'm curious if you have any comments on that, Mark.
Well, yeah, there's really no coincidence there. They're enormous explosions. The source of the energy is very different. So a nuclear blast comes from fission and or fusion reaction energy, nuclear energy. The energy of an asteroid explosion comes from the kinetic energy, which when something is moving as fast as these things are when they hit the Earth is enormous. And at the nuclear explosion level, I mentioned Chelyabinsk, the 2013 event, and that was about a half a megaton explosive energy. The energy is released in a very different way, but it is very abrupt on kind of the time and spatial scale. The big difference is nuclear explosions have very small amount of mass and a very small amount of momentum. Momentum is mass times velocity. They're not going nearly as fast and they don't weigh nearly as much. So when they explode, it's like a point explosion and it's mostly energy. Whereas when an asteroid explodes, it continues, because it has that momentum that it must conserve, it continues to move. So it's like a moving nuclear explosion. And that's why in that Libyan Desert Glass documentary animation, it showed it continuing down to the surface and then spreading out when it hit the surface. So they have a lot in common, but there are some fundamental differences as well.
Okay, and just for reference for the viewers, I believe Hiroshima and Nagasaki were 15 to 20 kilotons.
Yeah,
and
in that range.
The W.
There's also a difference in the way the energy is partitioned.
Right.
A larger percentage of the energy of a nuclear explosion turns into photons. So they're much more heat and light comes out of a nuclear explosion, as well as ionizing radiation, and it's a smaller fraction of an asteroid explosion.
Right. Now, for further reference, the W-88 warheads that we have in our subs going around the world are 475 kilotons, so about a half a megaton. And we don't want to be doing anything with that, I would say. But are you ready to dip out and get back into the other chat with the membership so they can ask questions?
Are you asking me?
Yes.
Oh yeah, yeah, anytime.
Okay.
And I probably, if it's another Zoom meeting, correct?
Yes.
So I think you might have to text me a link, email me a link. You've got. Okay. You sent me one by chat, I think, and I don't.
I will email you one. Here, let's see.
Okay.
Reply. That should be it.
Okay. So
I
can jump out of this and then jump back in on the other one. Is that the plan?
Correct.
Okay.
All right.
Great. Very good. Thanks, everybody.
You're welcome. And I'm going to go back to the waiting screen until I'm back in.
Okay. Thanks, Jesse.
You're welcome. And meeting it for all. Ooh, Cindy. Okay.
I felt like I just watched the second version of Interstellar.
Yeah. Well, I'm not sure who wants their face shown live and who doesn't. So, and here is Mark. So let's start with questions for Mark. Anybody? See here. If you have a question, Are there any that have been in the chat? No?
Ah, there we go. Okay.
Dave, surely you have a question. Oh, I was muted. So what you guys didn't hear is that Mark's open for questions.
This is Jack.
So, Jack, do you have a question? Dave, do you have it? Certainly Dave has a question. Can you all hear me?
Yeah, we got quite a delay in the audio here.
Oh, from me to you?
Yes.
Are you on the YouTube or are you on the
Oh,
Zoom?
I'm on the Zoom.
Oh, well, that's interesting that there's such a delay because it seems right away for you. Well, just waiting for somebody to pose a question. If not, then I guess we can chat with Mark if he's up for it and call the meeting an end. By the way, Mark, I will get with you and I will make a short video of the things that didn't show up well in the presentation. And your Zoom is muted, Mark.
Yeah, sorry about that. And yeah, I think that was my fault. I failed to mention that I had other videos in there.
Yeah, well,
when we tested it.
Well, that's fine. I can upload it as a separate video, and it'll work just fine.
Okay.
But the YouTube has me talking to nobody because I had my mic muted for Zoom, but not for YouTube.
Okay.
So, anyways, production problems. But it's not looking like anybody wants to ask a question. So
we have a question on the chat. So let me type that in on the YouTube chat.
Oh, excellent.
So it's from Reeb Feraldi. I'm going to put it in the, there is this weird delay. Reeb Feraldi asks, there you go. So she asked, on the fireballs reported by U.S. government sensors chart, are the negative values drag pressure produced by the fireball? That is the question.
Can you read that again? I'm not sure I understood.
Okay. On the fireballs reported by U.S. government sensors chart, are the negative values drag pressure produced by the fireball?
No, let's see, if I remember right, there was a scale on there which was a log in some units, and I don't remember what the units were, but I think that it was a logarithmic scale, and so there was a negative there. It crossed the zero, and so it's not negative numbers, it's just small numbers that have a negative log in the units that they were given in. Which actually I can rewind. I have the presentation up, and I can go back and look at it if you'll give me a second.
I think it was in kilotons.
I think that's a good answer. I've typed that into the chat.
It's log
back on
kiloton.
YouTube.
Yeah, it's log in kilotons. And so the lowest one, that's impact energy. So that's kinetic energy. And the way they do it is they have a total integrated brightness. So they know how many, so from the bang meters, they know how much visible radiation was emitted. And then there is an estimate, so I mentioned that nuclear explosions release a lot more energy as photons than asteroid explosions do. And so there's a range, and it does correlate with size. And so they do an estimate, and it's something like between 10 and 20% of the explosive energy goes out as radiation. And so, because they know the amount of energy that went out as radiation, they can approximate the total energy. And that's what that scale bar is. In kilotons, in the logarithm of kiloton. You have to do it as a logarithm. So all those bubbles on that chart, they're color coded and they're size coded. And if you actually made it a linear scale, the biggest one would cover everything up and you wouldn't be able to see the small one. It has to be logarithmic because there's such a huge range.
Okay, we have another question from the YouTube. So I'm putting that in the chat. It's from Will Keener, who says, Mark, did the change in the size of Bears Ears National Monument last year affect the status of the Moonhouse site?
I don't think so. So Obama, I think it was I think it may have been his very last executive order before he left office. And I think it was the very end of 2016. It was right after we went there, in fact. He declared Bears Ears to be a national monument. That didn't sit well with some people. Trump came into office a week or two after that, or 3. And Trump caved to political pressure and he reduced the size of it. The Moonhouse location, as far as I know, is still in the National Monument. I think it's all still, I think there's still a National Monument. I think it's just much smaller. It's still protected. It was already a historical site, a designated historical site. And in fact, the guy, Don Simonis, who I mentioned, who turned me on to this idea that the Moonhouse had something to do with eclipses at that Pecos conference in 2015. He was one of the people who spearheaded making that a national historical site. So he was very familiar with it, and that's why he knew, when he found out that there were eclipses, he knew what the age of those timbers were that were used in construction. So it is protected, but yeah, it's a shame, and I hope Biden restores it to the Obama National Monument when he takes office in January.
Hi, Mark. This is Becky Rice.
Hi, Becky.
How are you?
Good.
I have a question regarding the sun dagger at Chaco Canyon. One of the things I noticed about it is that it indicates both equinoxes and solstice. Is there anything at the Moonhouse that would indicate the same thing?
I don't know. And I don't think there's been a lot of interest in the Moonhouse. I don't think there's been a lot of research. And I'm not, I'm a complete amateur when it comes to this sort of thing. We went there. The only time I'd been there was that October 22nd, 2016 adventure. And I didn't see anything that was obvious. I didn't see we were I was throwing dust so I could see the beams, and I was watching where they went. And it's well, if they built this thing, they couldn't predict eclipses. So they didn't know eclipse was coming, but they, maybe it was under construction, maybe it was built by then. And then if they saw another eclipse, maybe they would have pecked something in the wall to record it. But I didn't see anything like that. But I haven't been there on the solstice. I haven't been there on the equinox. And I don't know if anybody's tried to do that. I kind of suspect somebody's tried to do it, but I haven't seen anything. And I'm not a professional at this, and I'm not really that plugged in. I know there is a guy at Los Alamos that I haven't met. I don't know if he's still there, but there's something called, I mentioned it in my astronomy magazine story. It's called Rock Calendar Project or something like that. And he's very much interested in creating solid models and working out where there might be a display of some astronomical event. I mean, most of the ones that get displayed are going to be equinoxes and solstices because those are just the most notable. But I don't know if there are any. That's one of the reasons I want to go back, just to see. But I'm not, I'm not any I don't do this at a professional level. It's like, okay, if it's obvious, it's going to jump out at you, I think.
Oh, thank you.
Sure. I see there's a question that came in from Jack in chat. There is a several second. Oh, okay, that's not a, okay. I would think that the glass in the Libyan desert is being harvested for its value, but have not seen it being offered commercially. I think I have. I think you can buy it on eBay, and I think they do sell it at gem and mineral shows. It's definitely being harvested for its value. When we went in 2006, we had there was a sort of a tourist outfitter that took us, and they're super protective. Just like, I mean, anytime you go to a coral reef or any kind of ecotourism, usually the outfitters are more protective than just about anybody because that's their business. And so I did pick up some pieces, but I was very limited in what I took. And they actually had an armed guard with them. The Egyptian government required that an armed guard go with you and make sure that you're not like a major collector. And I heard stories of people who had been out there that had they were filling 55-gallon drums with this stuff. But the outfitters have said since they started doing it, probably 50% of the stuff that was there is now gone. They have taken to burying stuff, so they dig holes, and they, whenever they find something really good or like a really good spot, they collect it all up and they dig a hole, they throw it in a hole and bury it. But they GPS it and they know where to look. So they come back with tourists and they dig it up to show them, and then they put it back and bury it again. I mean, it's not a renewable resource, but in some sense it kind of is, because you have these big giant dunes, and those dunes are moving, and they are moving over the top. So they're as those dunes move, and it's only a few meters a year or something, but new stuff comes out. But still, it's just like everything, there's too many people exploiting non-renewable resources, including treasures like this. But I don't know how you stop it. I mean, the blessing is that it's super remote and it's right along the Libyan border, and it's not really that safe of a place to be. And I don't think they're running tours out there. I think since the Arab Spring, I think all that is pretty much ground to a halt.
Okay, I have one. I was in Barbados in probably around the summer solstice in 2002. And it was a beautiful evening. We're sitting out on the beach and this gorgeous view of the sky. And I see this fireball flashing through the sky and disappearing, and nobody saw it but me. I know I didn't dream it. And I didn't ask a lot of people because I didn't know anybody, but Bill nor my son nor my husband saw it. But do we have records of all these fireballs? Do we know we've got them all recorded, or we just had our best guess?
No, we don't. And the small ones are not recorded or kept. I mean, I don't know how big this one was, but if other people didn't see it, it probably wasn't big enough. And that was a date you said that was at sunset. The sky was still light.
No, it was dark. It was
dark. Okay.
Had just become dark. It was wonderful, a beautiful evening. So
Yeah.
first night there.
Yeah, I think the ones that I showed on this, the bubble chart with the colored circles from JPL, anything on there, if that had happened in the sky over you, nobody would have missed it. It would have lit up the entire sky. It would have been like a nuclear explosion going off over your head, although it was far enough away.
You mean if it had burned up at that point? Yeah, because I just figured it dropped into the ocean. I don't know.
Probably not. Probably, yeah. If it was anything that's big enough to hit the ground or produce meteorites, is usually a pretty big display. when it blows up in the sky. They don't all blow up. Sometimes they just ablate and slow down, and the last little piece drops.
Well,
anything else?
Any other questions for Mark? Well, I'm not
thank you.
hearing any speak
very
up.
much.
So,
good. Well, I'm
Yeah, it was
glad.
very fun.
Glad to do it. Yeah. And I'm sorry I haven't been more engaged with CESE. It's a great organization. I'm glad that I at least was a cheerleader when it first started. I was looking at the website, and it was sad that like so many of the original founders are gone now, or the early Tim Moy and Marshall, of course. Yeah, I miss them.
Yeah.
And I miss them a lot too.
Yep.
All right. Well, if there are no more questions, I will point out that Mark was one of the founding members of CESE. Again, if you want more content like this, and I will get better at production as time goes on, hit the like button and hit subscribe, even if you're just watching this as a playback. And by the way, for everybody who is wondering, yes, this will remain up on YouTube. And I will get together with Mark to get those videos up, and I will put a link in the description. It doesn't have to be today, but fairly soon, so that it's still fresh in people's minds.
I regret that I didn't think to announce this, but it is Asteroid Day, and Asteroid Day is all week this year. Normally, we're in Luxembourg for Asteroid Day Live, and those two videos that are missing are going to be on the Asteroid Day panel. Those were the two that actually I ended up sending them, and so you can put them up. I mean, we can do it both ways. But they will be shown on Tuesday on Asteroid Day. They've got programming all week. So go to asteroidday.org, and they've got stuff streaming right now, but it will be on the 30th, the anniversary of Tunguska, that they have what they call Asteroid Day Live, because it's been live broadcast from Luxembourg for the last 3 years. And they didn't want to change the name, even though this year it's a lie. It's not live. We pre-recorded everything.
Oh. All right. Well,
I have a comment I'd like to make if I can. I'm a retired scientist from Sandia, and I actually worked with Mark about 25 years ago briefly. And I reminded him that I think at Marshall's memorial service. Marshall was a friend of mine. But since I retired from Sandia, I've been more active in community affairs, and I'm currently the chair of the Police Oversight Board in Albuquerque. So if you're looking for another application of some scientific, if you have some scientific skills or math skills, it's amazing. I think physical science and the ability to do analysis is a really important aspect of improving policing. And there's certainly a lot of social science and very good social science is done in terms of policing, but there's always room for people who have analytic abilities, and that's one of the things that police oversight movement in the country is about bringing science or scientific method, essentially doing database policing, looking at what you do to see that it's effective, and as long as and other things that it's also not ineffective, it's not counterproductive. So there's lots of opportunity if you're interested in an activity that has reward in terms of community input and a personal reward that you feel like that you're doing something for the community, especially in these days. I'd encourage you to look at the efforts that are being made in terms of oversight here in Albuquerque and changes in the police department.
If you could send me some information, and on that kind of on a related topic, I've been very active on this nextdoor.com, which is it's kind of a clunky version social media. Their interface isn't very good. But unlike Facebook and Twitter and Instagram and all the big ones, their architecture is entirely different in a couple of key ways, which I think makes it much more useful for any kind of local social activism, science education, all the kinds of things that CSE is interested in, and NMSR. So the way it's structured is neighborhoods are only linked to nearby neighborhoods. So unless you form a group, if you just look at the general feed, you only get posts from people who live within a couple miles of you. That's one aspect that's really good. The next aspect is people have to use their real names. You have to be a real person. You have to, in order to get an account, you have to prove somehow, they send you a postcard is usually the way they do it. And then there's a code on the postcard, but you have to have a physical address and you have to use your real name. Okay. So you can immediately see that gets rid of, Russian trolls, homegrown trolls, multiple accounts, people who are just there to make trouble. I mean, there are people that are there to make trouble, but they have to use the real names. So, and 3, there is some level of fact checking and moderation, and Nextdoor, to its credit, has taken a very hard line about misinformation about coronavirus, misinformation about elections. I can't remember what the third, there's 3 they highlight. I can't remember what the third one is now. But any kind of dangerous misinformation that hurts a community, they nip in the bud. They don't, they try to there's rules against things like soapboxing, and, people for the most part try to stay within the lines, although people go right up to the edge and some people cross them, and you can get away with crossing them, but you can't get away with it over and over and over. And so I've actually created groups. And Nextdoor just started allowing groups to be created that are visible to entire cities or metropolitan areas. So the groups can get pretty big, and you can join a group and now make connections with people that don't live in a nearby neighborhood. So I think I'm the moderator of like 5 groups now. And one of them, there's a coronavirus one that's gotten up to 500 people, and people from all over, people downtown, and you actually start making connections to like-minded people around town. So I think it's underutilized for local social activism, local science or education. I mean, I could see, a science education group would be a very, very good group that you all might want to think about forming. I don't think I want to moderate a 6th group, but I would definitely join it and support it. So I recommend everybody get on Nextdoor, join my groups, create another group, create an NMSR group or a CESE group, or just a general science. I have one of my groups is called Listen to Experts, and it's really it's about COVID-19 and overcoming misinformation and figuring out how to encourage people to wear masks and social distance and do all those things that some people don't want to do. So I can think of a lot of different groups that others might want to form, and you're probably going to see a lot of the same people in a lot of the groups, but these are people who care, but I think you can get things done because you can encourage, for example, members of the homeowners associations to join. You can engage with local leaders, and I think it's just another way, but it's not like Facebook where there's fake people and there's people butting in and there's people just causing trouble. It's not like that. And if you own a group, you can throw people out of it. Anyway, so if you have an Nextdoor account, let me know, and I can send you links to the groups. and help you create your own group if you want to do that.
Okay, I'm sure people will keep that offer in mind.
Yeah,
and if
I've joined
What's your contact information, Mark?
I'm sorry?
What's your contact information?
Oh, the best. I have a hard time checking more than one email address. I have more than one, but the one that I check daily, more than daily, is my UNM one, mbeb@unm.edu. I've had it for like 25 years. So
yeah,
if you have an email address for me, it's that one, mbeb, like Mark Boslough, E is in Echo Boslough.
okay, well,
At unm.edu.
unm.edu.
Thank you.
I put it in the chat too.
all right.
Okay.
I joined the Nextdoor, and I joined the Socorro group, and I'm we're getting messages about events here in Socorro, so that's kind of neat.
Yeah. I mean, I think one of the things, there are troublemakers, don't get me wrong, there are troublemakers on Nextdoor, but they're a pretty small minority, and there needs to be more reasonable people, because you can shut them down. You can literally get them kicked off, and I have done that if they get too far out of line. Or, if they're trying to stay between the lines, you can pretty much just say, here are the facts. And you don't have to get in one of these flame wars like people do on Twitter or Facebook. I mean, I don't do that on Facebook. I just delete people. And I unfriended anybody who, and most of my posts on Facebook are now to only my friends. So
yeah,
it's just not worth it.
All right. Well, if there are no more questions, I'm going to.
Question, please.
Oh, Ken has a question.
Yeah. So I watched this documentary on the fellow who was titled Mr. Tornado. And I noticed he got his start with the nuclear explosion over Hiroshima and was showing photos of one tree totally erect, the shaft.
Yeah.
Branches, okay. And then all the other trees laid out flat on the ground in this kind of a circle. So I noticed that in one of your photos too. Is that the same thing?
That's a thing, and there's a reason for that.
Yes.
And it was actually pretty well understood pretty early on by the Russian investigators. The Russians referred to those. There wasn't just one. There's a whole area, acre or more, of erect trees. All the branches are stripped off. They call them telegraph poles, because that's what they look like, telegraph poles. And it's because the explosion was 8 kilometers up. Something, it was in above the tropopause. And so think of a point explosion. I mean, it wasn't a point explosion, but you think of an explosion, the shockwave directly underneath at the epicenter. Well, the shockwave's coming directly above. There's no lateral force. There's a vertical force.
Right.
And behind so there's an overpressure followed by a big slug of compressed air that's moving at very high speed with very high dynamic pressure. And so when it's moving straight down, it's just stripping the branches off. Maybe stripping some bark off, but because there's nothing to push the tree over, you have a naked tree standing there afterwards. And then as it moves outward, the farther your range is from the epicenter, the larger the horizontal component is of that blast wave and the slug behind it that's got momentum and pushes. And so then the farther you get away, there's some sweet spot where the dynamic pressure maxes out, and that's where the trees are all down. So and as you go out farther, the shot gets weaker, and so only the weaker trees, or the trees that happen to be like on an upslope or something, that magnifies the wave. And then, of course, there's also the Mach stem amplification from that. So it's not super simple, but it's pretty simple to explain why they're standing up at the center. Yeah.
It's the same thing then as some of the things you're speaking of. You get the same effect.
Very similar, yeah.
Okay.
So that was Tunguska, but Yeah, a nuclear explosion would do the same thing. Only the nuclear explosion would have a lot more thermal radiation and stuff would burst into flame too.
Yeah.
Sure. Okay. Thank you very much. Appreciate that. Fascinating presentation. Thank you.
Good. Well, thank you.
Yes.
I have a
it's
question.
A little unusual to I don't know how like Stephen Colbert and those guys do it, because they're used to saying in front of big audiences and getting reactions. How do they time their jokes if they don't get a reaction?
He was a disaster the first couple of shows, and I got disgusted. But great to see you again from our environmental days, man.
Thank you,
Mark.
Ken, I have a question for Ken. Are you on the YouTube? Are you Rezon 1043?
Yes, that's me. So just ignore my little business.
Yeah. So the problem you had on YouTube was that you must have had two things: the Zoom and the YouTube, and that's why you got crosstalk.
We're still streaming. We can take care of this outside of the stream.
Yeah.
No, I figured it out.
But wait. We're still streaming live to YouTube, and everybody's going to hear all this discussion.
Oh boy.
Yeah.
So yeah, let's kind of back off on that. Are there any other questions for Mark?
I have a question, but I'd like to do it on Zoom, and people can leave if they wish, except for Dave.
Okay.
This has to do with an observation I made a number of years ago, and I've never been able to explain it. It was driving down the street, actually driving east on Constitution, somewhere around from San Mateo on, in the evening, just getting dark, looking up in the sky and seeing this bright light, and it just sat there, and it was very, very bright. And I thought it was an airplane coming in for a landing, or and just happened to be on the approach path or something. And no, there's no approach coming from that direction. And it lasted. I drove about 5 or 6 blocks, and at the end of that, it went, and I got see red and green sparks like a pinwheel almost. And so I sat back and did what you did. Said there's got to be an actual explanation for this. Yeah. And the only thing I could think of was that there was indeed some sort of object coming in very fast, and at the end with the red and green sparks was its final disintegration. But it lasted for probably at least 90 seconds, maybe 120 seconds. Any thoughts?
Well, if it lasted that long, it was going, from a cosmic perspective, it was going very slow.
Right.
But satellite reentries where they're coming in, and atmospheric drag is slowing them down, and they're only starting off at orbital velocity, which is like 17 kilometers per second or so. Right. Whereas, an asteroid, a meteor coming in is more than twice that and coming in steeper. So the combination of going slow and going sideways can make something last a couple minutes. I don't think it's unusual for a satellite reentry to be visible for a couple minutes. And if it happens to be coming straight toward you,
great.
Then, although I would think, it's not going to be, if it's coming straight toward you, that implies that it's actually descending, unless it's really far away. If it's just because it's skimming through the atmosphere, it's moving horizontally, but just from the geometry, if you're standing on the ground and something's moving horizontally and it's actually horizontally where it is, which is not your horizontal, it's going to probably look like it's rising. Its elevation angle is going to be increasing if it's coming straight toward you.
Yeah, it just stayed in one spot. That's what puzzled me. I was saying, boy.
Yeah.
People
it might be that the elevation angle is rising so slowly that you don't really discern it, especially if you're in a moving vehicle and you don't have any really good steady reference points that if you were like stable and on the ground and looking through a window or something with a frame, then you could see how it was moving relative to fixed objects. in a car, it might have looked like it was stationary, but maybe actually wasn't. It was just moving so slow in a angular sense that you didn't really notice. It just felt like it was stationary. Does that make sense?
Yeah. I've kind of fuzzed over those things before. Yeah, you're always looking for a magic answer right away.
I mean, the way to if you could remember exactly when it was, and you could go online, because they do. There are, there are organizations that publish satellite reentries and whatnot. I mean,
years ago.
Well, it wouldn't have. Yeah, I mean, every once in a while, you see the ISS go by, and it's super bright. We saw one of those. Dave had the table, and we went out on the deck in MSR and watched one of those go over, but it wouldn't have exploded into sparks.
Yeah. You hope not. Oh, that was just an aside, almost, Mark.
Yeah, no, but it goes along with this. I mean, to me, those things, it's way more fascinating to try to actually figure out what something was than to just say, "Oh, it's aliens."
Yeah.
It's like, because there's an infinite number of ways you can be wrong, and there's only one way you can be right. And how is it fun to, it's like going to the beach and it's like, I found a grain of sand. It's like, no, I want to find something cool. The one thing that really is special, I want to find that. And that right answer is special.
Absolutely. Where are we going to Sadie's now?
I don't know. Sadie's
I wish we could.
I know. I'm very, very conservative in my risk.
We're high risk, Mark.
Yeah.
No Sadie's.
Yeah, I'll wait.
Yeah.
Yep.
There'll be a time.
There will be a time.
Okay.
All right. Wrap it up.
Oh. Yeah, there. Oh, no, it's great. Oh, what do we see? What is that? I can't tell what it is. Oh, the same guy. Oh, no, I was looking at Ken. Ken was showing us his T-shirt, and it was that the same guy? Oh,
No.
okay. Oh,
Einstein.
okay. I couldn't see. Yeah.
Starry Einstein.
Thanks, Jesse. Thank you. Well, I'm glad you got to practice this on me, and it's like I think we'll get better at it as we go. I think we're probably going to be doing this for a while, and it's good to have an opportunity to learn from mistakes. And next time, I'll make sure I'll tell you how many videos I have.
Oh, I had the sound off for YouTube. Anyways, I'm ending the show. Thanks for watching all the way to the end and putting up with my production mistakes. I'm not very well practiced at this for viewers, but I will get better